Converting and running digital multisim circuits in TINACloud. In this video, we'll demonstrate how to convert and run digital circuit files originally created in offline multisim formats like MS13 and MS14 directly inside TINACloud. Note, these converted circuits can also be run in the offline version of Tina, where you can perform the conversion process directly as well. Our first example is an 8-bit counter. This is a 2-digit synchronous up-down counter built using two 74191N counter ICs and two 7-segment hex displays. You can use the interactive switches to enable or disable the counting process, clear the counters completely, control the direction of the count, upward or downward. We have already saved the 8-bit counter.ms14 circuit file to our computer. Now, let's use the upload command to bring the circuit into TINACloud and convert it automatically. Now press the TR button and enable counting with the upward switch. The counter starts counting from 0. Let's wait until the U2 display reaches F. Then U1 shows 1 and U2 starts counting from 0 again. Disable counting with the upward switch. Clear the counters. Change the direction and enable counting again. Now the counter counts downward, starting from FF. Note that if you replace the switches with TINACloud's digital high-low switches, you can create a fully digital version of this circuit and observe the digital states of all nodes. Press the Dig button. Next, let's look at a mixed-mode circuit, a digital dice. This design features an NE555 analog oscillator providing clock pulses to a CD4017 digital decade counter. We have already downloaded the MS14 format circuit file to our hard drive. Let's upload it into TINACloud using the standard procedure. The CD4017 is designed to convert incoming clock pulses into a sequential high signal across its 10 decoded outputs Q0 through Q9. However, notice that output Q6 is connected back to the master reset MR pin. This means the moment the counter reaches 6, it resets to 0 instantly. As a result, the circuit effectively cycles through positions 1 to 6. To see it in action, start the simulation by pressing the TR button, then click S1 to close the switch. The TINACloud logic indicators will now light up one by one, moving from left to right. When you click the switch again to open it, the clock pulses are interrupted. The counting stops immediately, leaving one of the indicators high at a random position between 1 and 6. This is why this circuit can be considered a digital dice. If you close and open the switch repeatedly, you'll see the sequence freeze at a different indicator almost every time, demonstrating the interaction between the continuous analog oscillator and the digital counter. Our final example features an 8-bit PIC microcontroller. Note, while microcontrollers are supported only in the offline version of Multisim, they are fully operational in both the offline and cloud versions of Tina. This LED blinker circuit periodically toggles an LED on and off. To move it from Multisim to TINACloud, we need both the circuit file and the microcontroller program file. When you save the PIC-LED-blink.ms14 file in Multisim, it doesn't automatically export the .asm assembly file. To do this manually, double-click the MCU symbol in Multisim. Go to the Code tab and click Properties to open the MCU Code Manager. Click the icon on the right side of the Show Machine Code file line. In the file list, right-click PIC-LED-blink.asm and open it in Notepad. Save it as PIC-LED-blink.asm in the same folder as your .ms14 file. Finally, compress both files into a single archive named PIC-LED-blink.zip. Now upload the zip file to TINACloud as usual. The schematic diagram of the same circuit appears. Note that in the MCU symbol in TINA and TINACloud, the MCU program file is directly available. To see the MCU program file, which in this example is in .asm format, double-click the MCU symbol, then click the three dots icon on the right side of the MCU code line and select Preview. The assembly language code appears. Note that you can upload any assembly code here as well by selecting Upload. Now press the TR button and you'll see the LED begin to blink immediately. TINACloud also allows you to study the code execution using the built-in MCU debugger. Enable MCU code debugger in the analysis menu. Press the TR button again to launch the debugger window. From here, you can use the Step button to execute code line by line while monitoring registers and memory. You can also set breakpoints by clicking on a line of code or using the breakpoint button. Press Run and the program will halt at your designated points. Pay close attention to port B, which directly controls the LED. C code and Arduino. While assembly is powerful, you can also program MCUs in TINACloud using C. Let's open PIC LED Blink Code.tsc. This circuit looks identical to the previous one, but the PIC is running on C code. Press the TR button to start the simulation. Double-click the MCU and click the three dots at the end of the MCU code line, then select Preview to view the source. As you can see, C code is generally much easier to read and follow. You can debug the C code in a very similar way to assembly code debugging. Note that nowadays the so-called Arduino platform is more often used because of its ease of use, instead of directly programming MCUs in assembly language or even in C. The Arduino platform is also supported in both TINACloud and TINA. For more information, see our Arduino tutorials on our YouTube channel, www.youtube.com/TINA Design Suite, for example, Arduino blinking LED simulation using TINACloud. For more information, visit us at www.tina.com or find us on YouTube, www.youtube.com/TINA Design Suite.